Today I'll be showing you how to hook up a PIR sensor, which is a passive infrared sensor. This could be used to detect motion, and once the motion is detected, it will give out a certain amount of volts, about 3.3 volts and very little current, which you can use to light up LED or even connect to transistor to drive a higher load when motion is detected. That is, when there is motion, something should happen. Maybe turn on the light, turn off the light, or do whatever. So once the sensor senses motion, you can now program it to do something. So watch this. As I move my hand here, you could see how the light comes on. And so that's the little way, as far as the current or little voltage can be passed through once my hand triggers. That means you can connect it to a transistor to drive a higher load or do complex tasks. But this is the simplest thing you can't do with a PIR sensor. Let me show you how it's been done. To start with, there are some components that we would need. We will need our 12 volts adapter. The PIR can withstand at least from about 5 volts upward to like 12 volts. So I think the 12 volts adapter should be perfect. We will need a PIR sensor. We will also need, well, the LED just to test it. We will need a resistor, perhaps to limit the voltage to the LED, and some jumper wires. Now, to hook this up, there are some things you need to pay attention to. You need to note that the far left is your ground, the far right is your positive, then the middle is the trigger. That's just it. So I will start with the hookup. I want to connect. I have my positive with the orange, and the far left is your ground, far right is your positive. The middle, which is the red, is your trigger. Now let's connect it. Remember, the far left, which is on my own, I have the brown wire, which is the ground here. And the black is my positive in this case, just switched around, ignore that. And I have the trigger, which is the middle one, connected here. Based on my calculation, if you remember my previous video where I calculated the resistor value for the project, I have a 3.3 volt coming from the PIR sensor. So I'm subtracting 2 volts, which is the forward voltage of the LED, divided by the ampere that the LED will consume. That's 20 milliamps, which is the same as 0.02. That's if you divide 20 milliamp by 1,000. So you now have it as the answer will be 65 ohms. Well, as you know, we don't always have these values like 65 ohms. I have 85 ohms, and it should just do just fine. And I'll connect my 85 ohm resistor in to my circuit, and let's see. So it's time to connect the LED. Remember, positive is the longer one. So I have the positive connected. Then you need to connect the ground of the LED to the ground of the 12 volts. That's the same ground that the PIR sensor is using. So I have my ground connected. And there are two important things you should know here. This right here is for to check, to regulate how long you want the signal to be passed if the sensor senses any motion. So if it senses motion, I can increase. If I'm turning clockwise, I want it to continue to send signal, perhaps to leave the light on for a longer time, clockwise. Counterclockwise or anti-clockwise would reduce how long you want it to leave the signal on. I've turned it to the barest minimum, so it should be about some microseconds after it detects signal, it goes off. You also have this to tell you to regulate how sensitive you want it to be. I guess you should be able to go about 7 meters sensitivity, and about almost, I think, 180 or 100 and something. So I'll check the data sheet to confirm that. But you can regulate how sensitive you want it with the left one. The right one, that's the variable resistor there, you can regulate it all the time. You also have the bridge to, perhaps if you remove this and fix it on the other side, we have the L bridge and the H bridge. So it's just for you to maybe continue to trigger. So once it senses somebody there, it keeps sending the signal until the person leaves, then it starts counting it. It starts doing the countdown. Or once it senses the signal, that's it. It just starts counting and it doesn't bother to continue to trigger until the person leaves. So those are the options you have, but I've set it to the barest minimum, so at least it should be fine. Now let's connect and see. One thing you would note with this is when you connect it to power, it might not give you a reliable reading immediately. It might flicker, because it needs to charge, and after some minutes, then you will get a reliable signal from the PIR sensor. So sometimes you might need to wait it out for about 30 seconds for it to stabilize before you can get reliable trigger and all that. Now, as simple as that, the circuit is done. It is time to test the circuit. Now that the wait time is over, we can now test and see if our connection is perfect. You could see just with the motion of my hand and the LED light comes on. So that's just it. Remember to like, subscribe, and support our channel. Thank you. Now, in the next project, you would see where I would connect this PIR sensor to the mains. Actually, that's the main power source. So it's going to drive my 220 volt LED. And you've seen that in my previous video. I did a short on that, but this one I want to show you the process and modify it so I don't have to use any external power. It gets the power from the main, it's regulated, and just come join us in the next session and you would see the process.